Hello and welcome to today's live stream. We're going to be talking all about how to build a pocket-sized cloud that can fit on a Raspberry Pi that allows you to run your own code on your own terms, however you like. We have a special guest, Martin Woodward, Director of Developer Relations at GitHub, who's also a big fan of Raspberry Pi and sort of trying to find out which one of us owns more of them. But without further ado, here is Martin.
Hey, how you doing? You can claim to have that honor. I don't want to quite admit to how many I own, but yeah, one of the problems and one of the reasons why I want to chat with you is because I find myself like buying a new Raspberry Pi for every single thing I want to do, and it just seems crazy because I'm nowhere near using half of them that I have sat running all the time. And you've been talking to me about FASD and about running containers and things on my Raspberry Pi, and I was like, you know what, it's finally time. I bite the bullet and go learn. So thank you for taking the time with me today. I appreciate it. And thanks for following along, everybody.
Yeah, I see we have a couple of our regulars. Johan Siebens here. We've got Donald Gover, someone naming themselves KK. It's like Kubernetes reference. And we've got Matthias.
Hey, Matthias. Good to see you.
Hello to all of you.
John. Yeah, it's great. Thanks for joining us.
I know that at least one of you here has actually contributed to FASD in the past as well and has done quite a lot with it, because it really started off as a way of running functions or OpenFaaS with the absolute minimum possible. So getting rid of Kubernetes completely, effectively making this distributed system into, well, an appliance, if you like.
Yeah.
And that's what's going to allow us today to build a pocket-sized cloud, which has an API that we can deploy stuff to. And it just so happens that GitHub Actions, the current version of it, is really well suited to building containers, has authenticated one-touch access to a container registry where you can push them. You don't even have to configure a Docker registry like we used to have to in the past. And it just makes it incredibly easy to put some code in a repo, have that triggered, build an image, put the image into a container registry that GitHub hosts, have it deployed to OpenFaaS, all in one shot. And it gets you quite close to that Heroku experience of, just writing a bit of code and it being bundled together and deployed. But I also think there's interesting things that you can do with it beyond just building a cluster. And I think a lot of us have probably built these clusters and then we don't use them because we don't really have a use case for them. And so I want to try and approach it almost from a different angle. If I put up my recent blog post on the pocket-sized cloud, so I wrote this as a kind of preparation. And you see here my Raspberry Pi 4, but also 02. And what we've got today is quite handy given the current situation where you just can't buy a Raspberry Pi for love or money. And if you can, it's probably not, an 8 gig version 4. This is meant to work on almost any Raspberry Pi, not any, Raspberry Pi 3 or a 0 W2. It's a minimum. And as you can see here, I actually have one of these I've been running for basically almost since FASD was created 3 years ago. It's got 7 functions on it that run 24/7. My total cost of ownership for that was an initial $35. That's what they were back then. And then I've got 4 cores, 32 gig SD card, gig of RAM. And so I can probably pack twice as many functions into that quite happily. Now, Martin, you have also I guess you have some thoughts on how you might deploy to Raspberry Pi. One of those is the GitHub self-hosted Actions runner. Actually happens to run on Raspberry Pi as well, doesn't it?
Yeah, again on the same Raspberry Pis that you're talking about, the ARM ARM 7 ones.
Yeah, 32-bit.
Yeah, exactly, 32-bit and up. The runner will deploy on that locally, and I've had that running fine. But again, one of the reasons for I have a cluster, and I'm going to just do this and mess with the camera a bit so people can see. I have this fancy, like exactly what you said, Alex. I have a cluster of Raspberry Pis that I've built, and I used it to calculate pi, and that was about it, and then kind of gave up. And I wanted to use it for some other things. And one of the things I was thinking it'd be cool to, on my controller node, to have FASD hosting some containers that contain the things that I want to do to then deploy stuff to the cluster and do a bunch of other things. So I was thinking about running, for instance, the runner in a container, using FASD to like host that side and then go play with the rest of the cluster and all that sort of stuff. So yeah, I'm kind of showing off by showing 7 pies in one there when nobody can get them anymore. But there we go.
No.
I own all the pies, so that's what happened.
When I wrote this blog post, I've heard in the past people say, well, the Raspberry Pi isn't suitable for production, and that's their main reason. Quip, maybe Hacker News is their go-to comment about them. However, the compute module can actually run with an NVMe SSD, just like your cloud instances, plugged into a PCI slot.
Yeah.
So that's about as production as you can get. And if you look at what Amazon offer now, I don't know if Azure are doing it yet, but you can get an ARM instance, a bare metal ARM instance, or a thin slice of a VM, which ends up looking pretty much like the Raspberry Pis we're using today.
Yeah. And the power consumption on them's, insanely good. And and it's with the GPIO access that I enjoy as well. And, on all that sort of stuff. So you can attach it to sensors, you can attach it to cameras, you can put them in strange places. I have a Raspberry Pi sat up I've got like a garden room at the end of my garden. And I've got a Raspberry Pi sat there that looks for meteorites. It's part of the UK MON network, and it scans the night sky every night looking for meteorites and fireballs, and then joins up with a bunch of other people. And we did the Grow Lab thing over the summer.
Yeah, of course, last year.
Yeah, exactly.
You went 31 other people and myself. We built our little Grow Labs, and we hooked up sensors and had them running. And that Raspberry Pi was sort of dedicated to that task. It was an appliance. It was deployed. That was its purpose in life, and we collected sensor data from it. And those use cases, I think, are interesting because people can understand them clearly as what they would do with it. Same with a media player or retro gaming for your kids, ad blocking. I've tried all of these. And we still end up with a few that aren't really doing anything. And one of the things you said to me is that quite a lot of people use GitHub Actions now as a kind of like cron runner.
And just like as a random serverless compute engine, you know what I mean?
Yeah.
And they definitely use it as a cron runner. So they would use it for scheduled tasks, but it's really deliberately bad for running scheduled tasks because
why is that?
Well, so it's designed to, especially the free tier is designed for providing open source projects resources that they need to be able to build and deploy and run as open source projects. And what we were finding is that like people would everybody sets a scheduled task to run at midnight on a weekday to go do something or like do something else. And so what we do is we know you've said midnight on a weekday, but we probably know you don't really care about it being exactly midnight. You just mean overnight. And so to try and offset that load, we'll deliberately kind of spread when those jobs trigger by a random amount around that time to not make it as peaky, to be able to spread out the load. Because even though it's unlimited build minutes for open source projects, we have a finite number of servers sat in the data center, So
the true definition of serverless is that there is a finite pool. At the end of the day, there's always a finite
it's
pool.
Somebody else's.
It's just someone else's problem, right? And so,
and I've done a lot of stuff I've done stuff with functions before as well, and so that was kind of
functions and what have you.
Yeah, mostly with Azure functions and a bit with Lambda and stuff like that. And
so one of the thing about those is that your Raspberry Pi cluster is going to feel like, and I make a reference to Raspberry Pi clusters in this blog post, it's going to feel like AWS to some extent or OpenStack on premises. You've got a pool of compute. You can talk to it through an API, and you've potentially got shared storage. And this is what NIST defined cloud as. And this is an updated definition because it's been changed a couple of times. So It should be convenient on-demand network access to a shared pool of configurable compute resources, network servers, storage, application services that you can provision rapidly, minimal configuration. So I thought, well, given the shortage of Raspberry Pis, given that actually if someone's running a cron once a day, they don't need 10 machines to do that. One is probably enough. Perhaps we could get to a pocket size definition for this stream.
Yeah.
And this is where FASD comes in, because it still gives us a REST API where we can treat that one machine like a pool. And what we do is we say, look, this is the container image. We've put our code in. It runs HTTP. We deploy it to the OpenFaaS gateway. At that point, the gateway pulls that image down, starts running it, and any requests that come in get routed through that. But they also talk about the convenience of this and being rapidly provisioned. Now, we're probably going to be slightly... We're not really done this to a stopwatch, but in a few moments, you're going to rapidly provision FASD on your Raspberry Pi.
Awesome.
And my point here is that yes, you have a single point of failure for everybody who is a cloud architect on this session. But you only have one toaster in your house. You only have one cooker. You only have one washing machine, probably. And goodness knows how many other things, one car potentially as well. And so we're used to that. Now, if your washing machine breaks, it can take you potentially a couple of days to get a new one. If AWS goes down, you're pretty much at their mercy until they fix their problems. With Kubernetes in the cloud, again, I'd be surprised if you could restore production in the time it's going to take Martin to flash an SD card and install FASD. And that's really the point here, is we've got something that's extremely simple. It's like a toaster. You put bread in and you get toast out. With this one, you put your functions in GitHub Actions, you get an endpoint out, we can schedule them, and you can write in whatever language you like as well.
Cool. And for me, this is very much a learning thing as well, because I've used containers, but I'll be honest, I haven't actually used the GitHub container registry much at all. And I hadn't done much of, like I've built Docker containers, but I don't really understand it properly myself, which is why I wanted to build all this stuff up, just so I could go play with it and go learn it. And I learn better when I can see what I'm playing with. I wanted to give a quick shout out to some people in the comments while we're just about to get ready. So Lars was saying hi to everyone. And then DJ Adams was also joining in. DJ remembers doing JCL batch schedules on a mainframe. Believe it or not, I'm old enough to have done that as well. And I was a PL1 programmer with a bunch of JCL. So that's awesome. And then poor old MP burnt out a Raspberry Pi last week. I feel pain.
How did you do that? Leave us a comment.
Yeah. I've burnt out GPIO pins before,
yes.
MP. I've done that frequently. Yeah, and you forget, like, those pull-up resistors or pull-down resistors have a finite capacity, and occasionally you'll just freak sort them out. So, yeah, anyway, but it's great to see everybody.
Ihab is here as well, who designed the logo for inlets that we're going to be using later on. So good to have you here. Now, there was an architecture diagram for what OpenFaaS looks like, because if we're going to install it, we might as well have a broad idea.
Yep.
We treat it like a black box, like an appliance in the home. We don't ever log into it. There's no good reason to. Perhaps to look at some system logs. And this is the same with Kubernetes. And many of you kind of attempted to log in because you're used to doing that. The idea of Kubernetes is your nodes are sacred. They're configured once and you never go into them. You don't ever touch SSH. You use the kubectl to access them, get the logs. And if you're on a managed Kubernetes service or a clever one where your pod is actually not really even a container you can log into, it makes a lot more sense. So OpenFaaS, we want to use it in a similar way. Our computer, your Mac in this instance, will use the CLI, UI. We won't be using the REST API directly, but both of these two use that. 2, perhaps deploy a service or a function. And there's not much of a difference here. A web page written in React can be deployed to OpenFaaS. There's a blog post about that I wrote up last week. And it shows you how to create React app up, some of the things that we've done with it, whether you maybe want to deploy the front end to a CDN and the back end to a function that's on your Raspberry Pi or whatever. We collect metrics for all of the functions that are deployed as they're accessed, which means we can get access to a dashboard with Grafana, look at the latency, the errors we're receiving, which functions are getting traffic. And I do have a little bit in the blog post that we mentioned. And if people want to go and look at that later, in case we don't get time to show you it live, you will see it right near the end. And you get to create pretty charts, but they're actually telling you meaningful information. You want to know if you have functions that are failing, and there might be good reasons why. It might be a 404 or 500. The OpenFaaS control plane API has its own latency that you can monitor, and then we can look at how long our functions are taking, because sometimes if we get stuff wrong, they might be crunching away unnecessarily, wasting API calls and what have you. I also have examples of what I've built in the past and what I'm running. One of those, just to show you can run a full UI, is this treasure trove. And this is my GitHub sponsors portal. So thank you for GitHub sponsors. You can sign in with GitHub. So it's going through an OAuth flow. And then it's showing you all of my past emails to sponsors. And I mentioned this session that was coming up, how to put an NVMe boot drive on your computer like you did, how to debug Kubernetes, etc., etc. But that's all served through a function. Even sort of the HTML and building the links, etc. That's all done as a function. And then there's other stuff that, like a Derek, which is almost like a slash command. Some people do similar things with GitHub Actions now, but when we built this, there wasn't really any good way of slurping in all the events from different repos and being able to do something interesting with that. And sometimes you may just actually use your function to just filter something. So I filter tweets about OpenFaaS to remove OpenFaaS retweets from the stream of events from Twitter. I do that by having if this then that, post all of that data across. So like your Meteorite example, you could have a data stream from a product like this firing data at you. You can filter it, and if it's within a certain radius of your house, you could, I don't know, message yourself on Discord.
Well, and I have Home Assistant running on yet another Raspberry Pi, which can do a bunch of alerting and then could like switch lights on and do all sorts of stuff for me based on those.
That sounds fun.
Yeah.
So that's a basic architecture of OpenFaaS.
So is OpenFaaS everything in that blue box, Alex?
This is OpenFaaS on
it contains
Kubernetes.
Prometheus, does it, and everything else?
Yeah, we deploy these things as well, along with NATs. And what NATs allows us to do, so a queuing system, messaging system, is invoke a function asynchronously. And this is important with, for instance, GitHub sends you a webhook. And if you don't complete within a certain time, your server will assume that that failed or timed out. Therefore, we may take it on the asynchronous path instead, which is already there. And that will run in the background by being put onto NATs. Our queue worker will pull it off and then run it. And you could schedule like 100,000 things into the queue worker, and it will just run through them and burn them down, potentially even sending you a message when it's done, if you set one up. So you then get an ID back that you got when you submitted it, and you can correlate and tie things together.
Cool.
Now, we're going to have to play with Node.js. There are a whole bunch of different templates for OpenFaaS. The way you can look at them is template store list. And in my ebook, it tells you how to build your own ones. The other thing that we're going to try is the function store. And this is pre-canned, pre-made functions that give out some ASCII, or maybe we've got things like NSLOOKUP. We've got some machine learning models, etc. These are all packaged in containers. Some are built through CI, some are built manually, and then you can just run them and try them out.
Sweet.
And then the last thing that I'll say
is detection. Sorry, I actually wanted to do some of that stuff. So anyway, sorry.
Yeah, you can try that, but that model won't work on your Raspberry Pi, so you might have to rebuild that.
Okay, right, fair enough.
The main difference with FASD is that we don't have multiple nodes like we've got on Kubernetes. We don't have this kubelet component that's talking to containerd that's getting in between us and our code. And we don't have a clustered state. This setid is where Kubernetes stores all its state. So if a node goes down or a master, we can restore ourselves because setid is a database for us. We don't have all of that. we don't have we do have an API server. That's the OpenFaaS gateway. We don't really have a scheduler because we've only got one node. And so we get something that's really quite simple to understand. On our node, we run FASD provider that talks to containerd and schedules our functions as containers. And then we have under FASD the ability to run stateful containers, which we didn't have as easily on Kubernetes. And this is where you bring in things like Grafana, Postgres, because as an appliance, you might be slurping in all the data from Hack and use the top 10, but you want a pointer or a cursor of where you've got to. So you could store that in a database row, and then as you're running this, you could figure out what was new by comparing it, and everything can live together.
Brilliant. So it's, everything I need for just doing rather than needing all the stuff I need with Kubernetes, I can just go play with some containers and do functions.
That is set up in a compose file, but we don't use Docker or compose. It's just an interesting spec.
Okay.
And we have, as I mentioned earlier from the diagram, NATS set up, Prometheus for our metrics, the OpenFaaS gateway, our API for our mini cloud, Queue worker. And these images, we moved them over to GHCR about a year or two ago because we used Travis before the free tier ran out. Then Docker Hub started rate limiting people that weren't customers of Docker Hub. So this has actually been really convenient for the OpenFaaS project to be able to use GHCR.
Cool.
Now, let's go and should we start?
Blaze has just learned about the compose spec, by the way. So there we go.
Good. Oh, Blaze is here. Good morning to you. It must be quite early where you are. So I'm going to take mine off. Okay. So if you've got any questions, just feel free to pop them in as we're going along. What I'm particularly interested in is use cases that people may have.
Okay. So I just here have this is just my Raspberry Pi I'm logged into. It's I've called it there you go. It's just a base. Oh no, that's my Mac.
That's your Mac, yeah.
Let's go log into my Raspberry Pi then. There we are. Right. So just a base normal Raspberry Pi 4. It's got not a lot on it. It's fairly clean. I set up SSH before we did this, and I got some of inlets going so that we can expose this to the internet, but we'll do that later on probably. But otherwise it's completely clean. So I'm guessing I need to go to the FASD website and go install it. What's the best way? Is it a Git clone or is it a?
Do you have the book open?
I do have the book open. Do you want me to share?
Yeah, there's the installation.
I'm a proud owner of serverless for everyone else. There we go.
Good stuff.
Right. So this is the easiest way for people to.
If you look at the table of contents and the first page of that,
make me read the manual. Deploy your server.
Then,
right. Okay. Right. Blah 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 blah.
So this talks about the core services in that diagram again, the things that make up everything, and then we go down a bit more. Self-hosted or cloud, not too quickly though. That's if you were, so the options that we show here, or if you were going to install OpenFaaS with FASD on your own computer, you need a virtual machine if you're not on Linux, i.e. yourself. So you would use multipass. It's a good way of doing that. And then this one command that you've got selected, git clone depth1. And if people aren't using depth1 when they're cloning repos, give it a try because it gets rid of most of the history of the repo and then makes it a lot quicker.
Yeah.
So that's our first thing to do. And then we're going to go into the FASD directory and hack install.
What's that multipass thing? Because I wasn't going to do that. I was just going to
is from Canonical, and it's an alternative to stuff like VirtualBox.
Oh, okay.
Start
it's a VM in type thing.
A few seconds. Yeah.
Oh, cool.
Brilliant.
Nice. But I'm not going to do that. I'm just going to install it on bare metal. So right. Okay. I'm probably sorry about this. I'm probably going to do like a full clone as well, just because for FASD repo is not that big, and I never know. I might want to make some. Make some changes to it. Yeah, there we go. Right, Command C. Okay,
and then after that, although we're not going to do it now, FASD is also perfect to run on the cloud, and so we have a cloud in it or user data. Johan's pretty familiar with that, and he's also built out a bunch of Terraform modules for. Trying to remember them all now. Equinix Metal, Google Cloud, I think you might have even done Azure. And so you can launch a VM with everything pre-installed, caddy, HTTPS certificate. So this is the Git repo. And then if you go into the hack directory, that you can actually run it without going into it, /hack, and then
install.sh.
Yeah.
Okay.
And previously,
what could possibly go wrong running magic scripts that you've just downloaded off the internet?
Previously, I think just had a lot of steps for this, and different people in the community have helped us get this so it run on Ubuntu, will run on CentOS, and potentially other distributions to install all the base packages we need, set up IP forwarding for the containers. There's pulling in the CNI plugins because we're using all the same stuff that Kubernetes uses, but the reason that FASD is faster is because it's not going through all that indirection to actually get to the container.
It's probably now's as good. Wow, is this up and running already? Now's a good as time as any to mention I'm running over a satellite connection here, so I'm doing this via Starlink. Is what's happening.
Great.
Cool.
Now at the end of this, we've got a command that says if you look at that journal CTL, that's going to give you basically your last few lines of the service coming up. And you should see it pulling.
It does all the systemd stuff for me as well, does it?
Yeah.
Sweet.
Now, this is what you don't get when you play with Docker, and you don't get this when you play with Kubernetes. Why I like FASD is we're able to integrate directly with all the Linux goodies. And there you go. Sweet. It's been pulling the images, starting them. And we're good. We've now got the OpenFaaS gateway on port 8080, Prometheus bound only on the local host, which is what we want. And if you scroll back up, if you've still got it in history, there was a login command.
Yeah, it's like
we copy and paste that in.
cat. So when it installed, did it put like it generated a basic password for me? Did it?
Yeah.
Right. Okay.
Yeah. Don't print that on the screen, but if you do the whole command,
that's going to log me in using the CLI.
Yeah, on your own machine, and then we'll keep this. So we're going to Alt Tab to do that. Yeah.
Okay.
And we'll Alt Tab to your Mac.
Yeah. Bring up a new terminal. Do you want me to?
Bring up a new terminal.
Okay. And then on this one, do you want me to I should probably make this a different color. Do you want me to install like the FASD?
You should have FASD CLI already, have you?
Probably don't. I probably need to do brew.
I probably wouldn't install it from anything from brew that's to do with DevOps because it tends to lag behind so much. But if you don't have it yet, FASD CLI.
Sorry.
Okay. If you don't have it yet, you could just download it from Hub OpenFaaS FASD CLI releases. I'll give you.
Or I could run the CLI on my Raspberry Pi itself, couldn't I?
We don't want to do that. Remember what we said earlier.
Okay, go on. Tell me why. Because I'm trying to do it like
an appliance.
I'm just using it as an appliance and I never.
Yeah, and we're not going to install Docker on it, and we're not going to build on it.
Okay, sounds good.
So you need to go over and get a copy of the CLI. I can send you a link in the private chat on this, so I don't know if you can open them on.
Yeah, I'll figure it out. There you go. So this is bringing it up on the screen, and then
you need the Darwin one for your Mac.
Yeah.
And MP is asking, where can you get the book? Store.openfaas.com or openfaas.com, and then there's a big button for it.
What do I do with that? FASD CLI.
And you want to move that to. I actually don't get it that way. Right click on the URL on GitHub instead.
Okay. Answer. Yeah.
Copy the link.
Yeah.
Address and go back to the other terminal. Do a curl space -o.
One sec. Give me a second.
Do Control W to wipe that out.
Oh, Control W. Oh, look at that. Right. Curl -o.
FASD CLI.
Sorry.
CLI. And then dash lowercase s. dash uppercase L dash uppercase S, and then the URL. With any luck, that should give us the binary.
Sweet.
And then chmod that with an X so that we can run it. I think we spelt that right. It's okay. Still not quite there. We've got CMOS.
Gmod even. There we go. Right.
And then move that FaaS CLI to user local bin. Great.
There.
Yeah. Now, what we can do is we can connect that FaaS CLI to our API, right? Because I said earlier, we've got a mini cloud with its own API, and GitHub Actions is going to talk to that API later as well.
Mm-hmm.
So if you now can do FaaS CLI login.
Yeah.
And then after that, -- gateway HTTP // after, obviously you need space.
Okay.
Now, do you know the IP address of that node?
I do.
And it's on port 8080 as a default.
Yeah.
Great. And then we want single -s, which is password from standard in. Now in the separate window, so you can hit enter on that.
I'm going to go grab the base64 password.
And you're just going to cap that out by dragging it on your other monitor and then clear the screen.
Yeah.
Copy it on the clipboard.
Yeah, give me a sec. So it's basically, I'll clear the screen in a second when I've done it. But Command C. Just in case. Command V.
Yeah, just in case. Good.
And it did.
Okay.
Give me 1 second while it does the login.
So MP is asking, why is the ebook only $35? Well, that isn't for everybody. That's a scholarship edition if you're on less than $30,000. So if you earn more than that, there's a full price edition, but it's not a lot more. And then there's a higher tier that has a video in it, and we've got a Grafana dashboard that's been pre-made that you can see in the blog post. I've tried to do this with my other ebooks, like the one on Go is offer a scholarship edition, just because I know not everybody in the world has a high paying salary that's in engineering, right? So we
just quick. If once I've done them -s, then I do the password on standard in. What do I do to terminate standard in? Yeah.
And then if it doesn't accept it, do Control D.
Control D. Thank you. Great. I am credentials saved for. Okay. So I'm just going to hit clear and
clear that and bring it over.
Yeah. Always allow. Right. Hello. I'm back.
You're back. Okay. Now FaaS CLI list. And yeah, that's good. And we just change the login to list instead. You obviously want the -G again, the gateway. Okay.
Yep. Enter.
Yep.
Ooh.
There we go. Awesome. So
if I was to go to port 8081 on my, as I've still got the password in my clipboard.
Control click that actually. We should be able to.
Well, I'll just
type it in, and that will open up the UI.
Actually, if I go to Octopi.
So Jacob Estelle is while you're doing that asking about the net booting setup. Now Martin bought that last night actually, so thank you. And there's a couple of editions. One is like a very raw, you're a networking expert and you just want to see how I did it, and it's probably not great for people that've not done this before. And then there's a fully fledged edition with a video where you can see me going through all of the steps, see it actually working, because it can be quite complicated. I spent a few weeks iterating on it all, putting scripts together, and I maintain it as well. So that one, the net booting, you can run FASD on it afterwards if you want. But the idea of the net booting is you can run what you want. So it could be K3S, could be Docker. It could be probably not something like RetroPie, but you could if you want. It's just all of the basics that you need to be able to net boot and understand the networking. Cool. Okay, so we've got our UI open.
Yeah.
Probably tried the function store, just deploy one of the built-in ones.
Oh, so if I hit deploy new function in here, it'll...
Yeah.
Oh, all right, so do that.
You're only seeing the Raspberry Pi ones, which is a good thing.
Okay.
Because we don't want you to deploy something that won't work. So
yeah. So if I do node info, is that right?
Mm-hmm.
And then hit deploy. So I don't click on that.
You're going to have to wait because the FASD is doing a synchronous call. Click it again.
And do it in the command line if you want.
It's probably
there we go. Function created.
working, but it's synchronous. Whereas Kubernetes is asynchronous. That's another difference with FASD.
There we go. So if I invoke this function,
and that's pretty quick, wasn't it? That pulled that down over your
easy.
satellite from GitHub container registry. If you put the word verbose into the request body and hit run again, Matthias likes Figlet function. Yeah, it's a really good one. And then scroll down and you'll see all your CPUs.
Nice.
You see your network adapters, loads of really geeky information. Now that's a built-in function, but we want to deploy our own one through and build it in a GitHub Actions. So completely hands-off, just like a Heroku PaaS type experience.
Mm-hmm.
And what we have is we've got an inlets tunnel that I set up for you earlier.
Yeah.
And it's got HTTPS endpoint. And did you run it with systemd? Is it up and running?
No, I did not. Sorry. If I just get it up and running now, then hang on a sec.
Yeah, you can run it in a terminal or
I'll just run it in a terminal. Do it. Give me a sec. So do you want to explain what inlets is for people while I'm getting this up and running?
Yeah. So if you have some code on your computer and you want to access it over the internet, maybe you want to share that with someone else. There are a number of tools out there that could be quite limited, and they might put rate limits on you. They might be quite expensive. It might be quite difficult to configure. They may not work in containers. Obviously, we're working with containers or in Kubernetes. And so Inlets is a product now. You started as an open source project, it's now a product. And you run the server component on a computer that can see the internet, that has an IP address, like a DigitalOcean virtual machine. That will cost you about $5 a month. You then maybe create a DNS record for it, so whatever your domain is. And then on some private network, like your laptop or your Mac or Raspberry Pi, you can run the Inlets client. And so even though Node.js on my actual computer, my laptop, doesn't have an IP address, nobody can get to it in any way, the public server will work as like a proxy. And whenever there's a request here, it will talk to my client over the connection that the client started, so reached out, and then serve the traffic from my machine. Now I have a tunnel that I use for a bunch of functions, like whenever somebody sponsors me on GitHub, I get a notification in Discord. If those tweets get filtered, that goes through that as well. And the insiders portal that I showed you guys earlier, that's all working through this as well. So I set this bit up for Martin, and now he's going to run the client.
I was being dumb then. Ignore me. Sorry.
Localhost.
Yeah, no, I was being super dumb because I ran it on my I was running it on my Mac rather than my Raspberry Pi.
Well, you can do that. And if you run it on your Mac, you just change the upstream to the IP address of the
right, yeah. Well, I don't want to, but yeah, no, you're right. There we go. Right, I'm running it now on my machine, so I should be able to get.
You deployed what function?
Node info. Yeah.
Let me prove that I can get to it.
So I'm forwarding port 8080 to you.
I'm just took over the screen, and okay. I'm actually on your computer now. Your FASD cluster connection is secure, and I can see you've got 4 gig RAM, and it's been up for 4,000 seconds. I think that's seconds.
Yeah. That's scary. So everybody else in chat can go jump on my computer as well now.
Oh, let's see if I can log into the gateway by taking the rest of the URL off. Oh, No, I can't.
Nice,
So
but I can.
This is a TLS protected connection with a basic auth password, which a lot of people might frown on. However, it's an encrypted connection. The browser sending the password over that. It's pretty decent, and other companies can go and buy the SSO plugin if they need it. So I can't get to your Raspberry Pi to manage it unless I had your password. And this is where
you do realize this is going through space, by the way, Alex. You're talking to me via a satellite. So
this is one of those things, isn't it, that Starlink customers don't get public IPs, and
you can't even buy one. Yeah, you can't even put a machine on, in a DMZ or anything like that. You've no way of accessing my machine. So this is awesome.
I wrote this blog post a little bit ago, and one of the points that I was making is, yes, you can potentially buy a static IP, or you might have a dynamic one that you're updating. But look what happens when somebody puts that into an address bar. I know exactly where you live, and it's pretty scary. And if I don't know, within, let's say, a street, I might still know where the distribution box is. Now, if I go for an IP geo lookup, and I'm going to put in your IP address that you've got on your Raspberry Pi, which is Martin node 06S OpenFaaS. What are we going to get? So this is your IP, United Kingdom. Oh, DigitalOcean. So I'm getting blocked from knowing who you are and where you are, because it's going to the VM. It's not going to your house. And a lot of people are like, oh, I don't want to pay for it, for inlets or something like that. I can just forward my ports. Well, it's great if you can do it, but you are doxing yourself. You're giving out your home location. Probably not a great idea. Now, you can't also have more than one IP address when you do this. Not usually. You're using your router to port forward and go to different Raspberry Pis. With inlets, you can just keep making inlet servers, as many IPs as you want. Have 100 if you like. Get your own subnet. And it's far cheaper than buying an IP. They're quite hard to get at the moment. So that's...
Blaze was asking, does it support IPv6? Does inlet support IPv6?
It does.
Nice.
Yeah. And it's all as simple as running one command. There's lots of hacks that people could make. You could use SSH tunnel. You could do all sorts of
Nmap as well and stuff like that.
Right.
Things, but yeah.
But really, this is just one command and it's instantly running on any
Yeah. Sweet. Right. Let's go. We want to get some actions going. We've got 15 minutes.
We've got till 1:30. I don't know if you've had less.
I've got 45 minutes if everybody else has. That's good. Yeah.
So let's create a GitHub repo then.
Sweet. Okay, so I'm Martin Woodward. And then did I create one a minute ago? I think I just created one a second ago. So let's have a quick look here. Sparkle Pi. There we go.
Okay, good stuff.
But it's completely empty.
So... Okay, we'll clone that down.
Yeah.
And we'll start a function in Node.js. We'll use the Node 16 template for that.
Yeah, let's find out if I've got the right versions of Node installed and everything else here now. But anyway, hang on a sec. Right.
While we're waiting for that, what do people think of my OpenFaaS keycap custom printed?
So look.
Let me know in the chat. I've got one of these for someone who tweets the best photo of our live stream with the best comment, and I'll send it to you. I'll go down to the post office, send it to you this weekend. So
I'll throw you in some GitHub stickers into that as well.
I've got some GitHub stickers already. It's GitHub star, so I could chuck a bunch of them in as well.
Yeah,
if you want one of those, I'll dig out the bag from behind me and I'll send one over to you. And I've probably got a FASD sticker and an inlet sticker for you as well.
Yeah, here we go. This is where
the best tweet. That's at Alex Ellis UK or at OpenFaaS. Include a screenshot of our live stream, and you'll get that key. One of you will get that keycap.
Cool. Right.
We've got a repo. We're in our repo.
Got a repo. I probably just need to pull down Node 16 now.
We don't need Node.
Okay. Go on then. What do you want me to do?
Docker. You've got Docker, haven't you, on your
Nah, I don't have anything on my machine. I told you I'm terrible at containers. What do you want me to do?
Can we install Docker?
Yeah, okay, sorry.
I mean, we could pretend and just let GitHub Actions do it.
No, it's good. Give me a sec. Well,
Because I think you don't actually need to build it on your machine. But I put together a repo called FaaS, Alex Ellis FaaS the example. And
let's use that one. I'll just clone that one instead. I'll just fork it.
forks. Do forks work properly when you're running actions? Do you need to actually?
I'll do some magic. Yeah.
Yeah.
That's okay. So there's your thing.
That's gists. Yeah. And this is also in the ebook. So basically what we do is clone the repo. We set up Docker in a way where it can build to the Raspberry Pi or to cloud. We then have our function defined there. So just start off with a FaaS CLI new for me.
Oh, okay.
In your Sparkle Pi.
Oh, okay. What am I doing? FaaS CLI new. Yep.
Space -- lang for language. Node space node 16 space -- prefix, and this is your container registry. So gh, what is it? ghcr.io.
All right, yeah. cr.io whack
/
is that what you want?
Yep. And then at the end we're going to put the name, so you could just put Sparkles or something like that. No, I don't mean that.
Okay.
Put a space and then write it.
Yeah,
that would do. Yeah. So what happened was FaaS CLI cloned the repo called OpenFaaS templates, where we have all of our master templates in, and then it laid down sparklepy.yaml.
Yeah,
which is like the main configuration, and then SparklePy folder, which has a handler JS in it, like anybody that might have used Lambda or something like that before. And we've also got a package JSON in there, so if we want to install an npm module, we can do that too.
So if I just do a git add on everything,
let's rename the SparklePy to .yaml to stack.yaml. The reason is it would just be less for us to change. .yml.
Stack.yaml?
Yeah. It's a bit like how make files, if they have a non-default name, you've got to specify them, or Dockerfile if you change it. Now, if you cat out that SparklePy file, a stack, yeah. What we can see is that language template, where the files are that are going to be used for that. We've got the image there. And then to do it through GitHub Actions, what I like to do is use some environment variable substitutions so that we can inject in the image tag. So as we're building it, we could use the git char as the tag. So if you open your code inside is in this folder. And the syntax is in the other window. So if you go to my FaaS example, you put left and right aligned on the screen. So if that on the left, and then have the GitHub repo on the right.
Got it. I see what you mean. Yeah. What am I grabbing from here?
The stack. Go into my stack YAML, and you'll see the format. The last one, how we've got the environment variable substitution going on.
So
if you copy the image line.
Yeah, got it there. Yep.
Put that under yours. And then copy and paste Martin Woodward over Alex Ellis, and then SparklePy over repo summary. Because what I was doing this morning was I was writing a function that connects to the GitHub API and gets the summary of the top 10 repos that have been changed recently under my account. So their stars, their issues, just to try and do something like what someone might do with a GitHub action.
Yeah. So
Okay,
that's...
and then remove line 9 now. We don't need that anymore. That's looking good. And then all the other stuff in that example is just really, we've got things like a cron schedule in there. We've got a secret for my personal access token, and I limited it to only be able to read public repos. So I didn't want a God mode token or anything like that.
Where's that part? So secret's repo reader token. Right.
Yeah.
Okay.
So those get created either through GitHub Action or manually. And I did mine manually.
Okay.
And then under annotations is the cron schedule for running that every 10 minutes. So that's actually running on my machine now, and I'm seeing logs popping up.
Right.
Showing me what happened.
So what's that copy?
Yet.
Okay.
You don't have. I don't think we've got that configured for yourself.
Okay.
Right. Next, GitHub Actions starts with a .github folder and the workflows. So if we do the same, just the build file, let's take it verbatim across. So if you create that folder on your side.
Yeah.
I got this wrong the other day. I think I put workflow and I didn't know why it wasn't working.
All right. Yeah, definitely.
Paste it in. Now, at the end of this, we do have a login to the gateway, which is going to happen over, or it's at the top. So install the CLI from OpenFaaS, which we all did earlier. We then set up Docker in such a way that it can build for Raspberry Pi on a normal machine.
Nice.
We then get the tag, which is the SHA of our build from the commit. We get the repo owner, which is why you won't have to put your name in this because we've made it clever.
Well, you defaulted it as well to me, but yeah.
But not for this step.
Oh, okay, right.
And then we've got a login to the container registry with GitHub repository owner, again, like a generic step.
Yeah.
And then we got the password of the GitHub token. So at the top of this file, you see the permissions.
Yeah.
And it says write to packages.
Yeah.
And that's how we get the GitHub. In the past, we all used to have to create passwords on a Docker Hub and copy and paste it as an Actions password.
That's magic, isn't it? Yeah.
It's brilliant how it's been integrated. Yeah.
Yeah.
It really is. And then the publish command is what we could run on your machine if you had Docker.
I do now, but anyway.
Cross-compile to Linux ARM v7, so 32-bit. Now, is yours 32-bit or 64?
I think I went with 32 actually. Yeah. How do I
do you want to run that? uname-a, or not on your Mac, but on the Pi?
Dude, hang on a sec. I'm getting confused with all my shells.
It's okay.
That one. Yeah, there we go. I'm just checking there's no... Okay. I'm just going to clear the screen before in case. Right, here we go. Right.
ARM v7L. So that's that's the 32-bit. So we're matching. And you can actually publish an image for ARM v7, ARM 64, and Intel all in one shot, but it's a bit slower. We're not doing that. And then we've got the login. And what you'll see is we've got the URL for the gateway, which everybody knows now. So it's not really a secret, but we're going to put it in a secret. And we've got the OpenFaaS password. So these are the two things we need to go off and create in our GitHub repo under the Actions tab. So Action or Secrets Settings tab.
Right, I'm just going to bring that up, and I'll do the OpenFaaS URL
show
bit
people
first.
where it's going, and then we can do the other one off screen.
Yeah, okay, there we go.
Now,
so,
Blaze, you were asking about environment substitution. Well, what that means is that you can effectively have one file, and then you can inject the values in at build time, and that's what we're doing here.
So this is me coming in now, and I'm going to do the
this is your full URL with inlets and
Would you be able to dump that in the private chat for me if you've got it handy? Save me copy pasting it, or I guess.
Yeah, no, I'm getting it.
Awesome, thank you.
Let's remove the UI off the end of that.
Let's get my password right. Sorry. Thank you. Oh, okay. So that's just my node there. And that's your inlets nodes. That's why it's publicly accessible. And I want to take the UI. Yeah. Yep. So I don't need anything else on the end. It's just that.
Just take the slash off as well. I'm not sure if it's important.
Yeah, find out.
Then add the secret.
Cool. And then the next one I'm going to do, and I'll just move it when I do the
OpenFaaS password, and that's always on the machine. You can always go back and get it again.
Yeah, I've got it ready now. So there, and then give me 1 second. I'll just go do that. And then Command C, and then Command V, add secret. Boom.
Now, if you scroll on the line 53, just slightly to the left on that window behind, just want to show Blaze. He's not quite seeing the magic here. So in the deploy command, we've got FaaS CLI deploy is what we're actually running, but then we're passing in 2 environment variables before that, owner and tag. Those 2 variables are going to be put into the stack YML. If we hop over to that on the
I wasn't seeing that either. So they're coming into here of owner and tag. Got it. Fancy. That's magic, isn't it?
Someone's asking, who do we tag? Yeah, at Alex Ellis UK, at OpenFaaS for the giveaway. Yeah, and so this is brilliant because now the environment substitution plus this means there's no hacks, there's no seds. It's nice. I think we're good to do a save.
Yeah.
Do a commit and a push.
Yeah. Yeah.
And anybody sort of wondering what we're doing and why, this is detailed in the ebook serverless for everyone else, and that's the reason I wrote it. I just wanted to have something for FASD that there was no guesswork. It was fully documented, tons of examples, and they're all written in Node. So that also then makes it quite easy to know what to expect, how to access a database, and what have you.
Right. So now if we go to here, I've got that. If we go to the workflows, what was the trigger on the workflow? I didn't even look at it.
It's pushes.
The push. So it should actually be running. And if I go to my actions, wow, look at this, dude. This is magic. It's got the QEMU. So the QEMU is basically an emulator. So it's emulating an ARM64 background inside a Docker container.
That's what we're doing there. And then Docker we're using Docker build kit instead of a normal Docker, because that's clever. And then the OpenFaaS templates have also been made clever so that they can, in a similar way, inject the operating system that you've asked for and the CPU architecture rather than whatever's on the host. So we did quite a lot of hard work to make all of that work. So
yeah, because the host, this is running on an Ubuntu host. You know, it's running on Ubuntu latest, was it? Is that what we asked for? So yeah. Cool.
Right. So that's then installing the npm modules. At the end, it will push an image. Now, this image might be private, so you might want to go to your packages for your personal user account.
It will be by default.
Yeah, I get this a lot, and then I'm always having to change it.
I can't remember where it is.
It's at your user account level.
Okay. Sorry. Yeah. There you go. You see, it is confusing for everybody. And then I go to the
packages.
settings.
It's on the screen now in the middle-ish. Yeah.
Sparkle Pi. Click on that.
Yeah. And then, so MP saying actions in maintenance mode, but it seems to be working for us. So.
Are we having an outage at the minute again?
Okay. So go back. Oh, this happened to me as well, and I made my private repo public by accident. Go to package settings instead, which is at the bottom right. Yes. I actually made one of my repos public that I didn't want to. I just wanted the artifact public, and then all the way down. Keep going. Change visibility on the right. Click public, and then type in the name. Click public, yeah. Now we're going to have to kick off the build again, but we can just retry it, and that would actually be better than...
And we've just added some new functionality to do retry.
But where did we fail, first of all?
Okay, let's have a quick look. We've failed on the deploy node, which is where we're expecting to
Unable to pull image.
Yay!
Perfect. Right, let's retry that.
Look, rerun jobs. Isn't this amazing? This Actions just got better this week, so it's all good.
Yes.
Well, you know, if the CD build worked first time, people would know we were cheating. So this is good. So what does this? While this build's running, then what's this?
Yeah.
This is just a clean. Let's have a quick look at the.
Yeah, let's have a look at it. So whatever comes in, we're then we're doing a result where we're serializing the body as a string, and the content type of the request is then going to come back out again.
Awesome. So it's just like echoes what you send it, basically.
Yeah.
Brilliant.
Now, in the background, I might see if I can give that a go, actually.
No, not there yet. Let's give it a... So it's all, look, it's publishing to the container registry.
Oh,
come on.
Yeah, I'm curling it. It's giving me a not found because it's not there yet. Oh, it's getting close. And then the deployment is synchronous. So this is blocking for the time it's taking to pull over your Starlink.
So this is now deploying from Actions via outer space into my Raspberry Pi that's sat behind
Cosmic IP address. Yeah. And I'm going to curl it now.
Look, there it is.
Why can't I get to it? Am I spelling it wrong?
What was the... it's like Martin...
Oh, I'm not putting the word exit in there, yeah. Okay. So I'm going to show you that I'm actually accessing now. I'll just take the screen quickly.
Okay.
Here's my computer, and I'm going to do a curl. I'm going to put a -i because that's going to give us a bit more information. And as I said, like it's got my body that I put in, the content type. We get a call. We're getting a call ID that could be traced through logs, and the duration that it took. So if we were to call it again with a post, Elon Musk, you're now getting the body printed back. This is a form submission. Nice. And there's one more thing we can do that's quite cool is I can get an asynchronous call instead. And it's immediately accepted, and it will actually come back to you and get queued up into Nats, and Nats will drain that down and run that request for us.
This is magic. This is brilliant.
Yeah. And what I like about this is that now that we've set all that up, and that did take us a while because it's the first time we did it, and you know we were skipping ahead. You can just go to your repo now and let's change the message.
Yeah, so you know what I'm going to do? I'm going to do this. I'm going to hit the dot key.
Oh, I love that. I use that for browsing code all the time now.
Yeah. Look at this. This is so exciting.
If anybody hasn't seen this, this is an inline Visual Studio Code. You can hack on stuff. You can run any commands, but you can definitely edit stuff.
Yeah. What should we do? Should we just put something in the body, or
put another variable in the result?
So what
at the end of that, put a comma on line at the end of line 6.
Oh, sorry. Oh, okay. Yeah, and then just do like test or something like that. Oops. Yeah. Handset. Sorry.
Starlink true.
Yeah, there we go. But you know what I could do? Because anyway, sorry, the possibilities are now getting quite.
So we can save that now. We don't need a comma. And so what we've done is we've etched out some code. We've copied in from the ebook the code for building and deploying this via GitHub Actions. We've got an inlet tone that we created earlier, public URL. What we could now do is connect that potentially to a webhook event generator from a repo. That's something we were interested in. So are you going to commit that?
I just have.
You have, okay.
And then so Actions is running and it'll deploy it. And so you know what I've got though? So the Starlink boxes, the router on them actually has a JSON interface you can call to go get debug data out.
That would be cool.
Box.
Yeah.
Anyway, right. So yeah, so I'm sorry, let me get to actions. Yeah, it's running, it's deploying. So
there are clever things you could do as well, like potentially, submit into the job, into the check status, the URL of the function you've deployed. We used to have something called OpenFaaS Cloud that would do all of that automatically. So every commit you get a new function. We could even change the name of the function and inject into it part of the SHA, like the 4 letters.
Yeah.
All kinds of stuff. So now anything you drop in here, even you can add another function. Every time you commit, they'll be built, and the whole lot will be built as the stack, as that YAML.
So while this is deploying, let me just check I understand how this is working. So the stack.yaml is registering my functions.
And the lang is linking to the default repository for templates where the Docker files exist.
That's magic.
So that gets laid down first, then your files in that handler folder get laid down second, and then we build it.
That's magic. So then, and then the standard, I just, from any function then, module exports async event. Sorry, I'm just reading this.
The async means that you can do like a wait. So you could do a curl.
Yeah.
Well, you could use Axios to speak to your router.
Yeah.
Make a request, get the value back, and I think I have an example of
But
that.
basically, I'm just returning the context, and then, yeah, okay. Right, it should have deployed by now. If I want to, and it's like if
Actually,
I go to my,
can you go to page 21 in the book?
Yes, if I can remember where I've got the book loaded, in which tab. Give me a second. Yep, I got it. Page 20, what?
21 to 22.
Yeah.
Okay, this is interesting. I'm on a different page number on mine.
Maybe I've got an older version of the book. I'm on 1.2.
For Axios, which is under your first Java. Oh, yeah, it's 2 pages down, I think. Yeah, so if you full screen that, we'll give people a little preview, and there's still plenty to get by buying it. What we've done is very similar here. That was node 12 instead.
Okay.
That's our YAML. And if we scoot down a teeny bit, you'll see similar to what you've got. Go down a bit more. That explains the input and the output, the body, the headers. And then we're doing a curl into it. Go down a little bit further, and it's saying we can install Axios. So let's just try that. Let's install Axios. Now, how are you going to do that without having Node? Because have you got NPM working?
I dare say I do. Let me just check. You know what I can do?
Code spaces.
Yeah.
That would probably be better. We could have used that. Yeah.
So I'm going to do code, and I'm going to do code spaces, and I'm going to do a new code space. So rather than doing just my cloud, I'm using everybody's cloud right now.
Yeah. I think this just proves how convenience features like GitHub Actions, container registry, code spaces, the costs of these things can add up, but when you compare that to how much time you'd spend doing all this manually, having that convenience, I think, has a bit of a compounding effect. Now, don't do it in there. We want to go into the folder.
I've done it now.
That's okay.
Controls are gone. I can just delete
RMRF, the node modules.
RF.
You need to do an R as well.
Thank you.
That's okay.
Yeah, and then
just leave that package lock. It's not going to do anything. And then we want to CD into the Sparkle Pi. That's where.
Okay, sorry. I'm gonna delete that package lock anyway while I'm here. Yeah, just gone. Right, I want to go into the Sparkle Pi function, don't I? Sorry. Yeah.
And the reason we do that is because that's the context of our function, and our package JSON is there. So now you're going to paste in the command you've got. Yep. We're going to install the Axios library, which we can use to make a HTTP request. And then we're going to go back to the other bit of the book. We look at the handler, yeah. And go down a teeny bit. Keep going. We should see something like an import. Yeah. Const Axios require. Copy that across. Put that after use strict. Looks good. And then it's quite simple, really, if you look at it. Let's copy both lines. Let res and body equals. Let's copy all of it.
Okay.
And we'll overwrite all of our content with that.
Come on, you can do it. Come on, see. Can you see that all right, Alex? I'm trying to make the font
zoom in
bigger.
a couple.
How's that?
Control.
Yeah, no, my keys were messed up, so I'll do that.
Okay.
Right, go on.
All right. So now let's put your router's JSON URL into that URL instead.
Give me a second to find it.
It's okay.
192.168. But we can.
Anybody's connected right now, and you're wondering how you could apply this to what you're doing. Blog post that I've written. I'll just pop over to my screen. All about this, and we had a look at this at the beginning of the stream. Starts off by giving us a definition of full-size cloud from NIST. We then go and take a pocket-sized definition. We shrink it down for us, for a personal cloud. We say we want an API-driven cloud. So we want an API, the OpenFaaS API, to deploy from. We talk about what's included in OpenFaaS, what freebies you get, what goodies, why it's a lot smaller than Kubernetes, but it actually ends up using very similar parts. There's a pretty decent presentation you can go and watch about that. We've got some instructions for actually doing some of this stuff. Now, that's not necessarily the complete instructions. The ebook's going to be better for you. And then we build a function like you saw me and Martin do. And we install GitHub Actions on it. Finally, I think one of the most interesting bits is I talk about use cases and particular functions that I'm running on FASD, including Derek, which is a GitHub bot. You've probably seen that if you've contributed to OpenFaaS. The Treasure Trove sponsors portal that is actually a function, but we're seeing it as a React web page. My tweet filter that works with this, then that. My GitHub stars receiver that then goes to Discord. And this you're probably going to like as well, which is a Grafana. And so you can deploy that alongside and take a look at all these metrics that are collected for you. We probably haven't got time to do that right now, but the video that's included with the ebook shows you how to do that and what it looks like.
So I'm just trying to find the path to the to this raw JSON file is what I'm trying to do. So
a couple of people have asked about the net booting workshop. That is also over on Gumroad. And this is really to get your SD cards out of your machines. One of the things I just love about this is that you can then manage any of your Raspberry Pis remotely. So there's no SD card, but also that file system now exists on the server. So you can RM the directory and unpack whatever you like there. And when that machine starts up again, it can have a completely different operating system on it or something that you've configured. It's really fun just to actually see it work for the first time. It's 25% off at the moment. It's a video. You see me walking through it, showing you a picture of just behind my shoulder. You can actually see it there, everything that I ran. And you can put K3S on it. You can put Docker, you put FASD if you want, or don't have to use containers. Once it's net booting, you could even have your RetroPie net booting if you really wanted. And the one that we've been referencing the rest of the time is serverless for everyone else, which is basically like a handbook for which is that one. So what have we got, Martin? We found what we need. Oh, sorry. Somehow I managed to take you off the stream. Have we found that thing? The JSON?
No. So I was just gonna run it with yours.
Okay, let's do it with the astronauts, and this will show us who's in space, and hopefully that American astronaut that's up there will be able to get home soon.
Are they right? Am I doing that right? I don't want the node modules thing going. So
they're not showing up, so it looks like you've got it right.
Yeah, wicked. Yeah, right. So
what have we done instead? Because I accidentally removed you off the stream when I was talking.
Oh, okay. So all I've got here is I copy pasted the example from your book. So it's going to do a get on that JSON file, and then it's going to output it. That's right, isn't it?
Okay.
Should we see if it works?
If anybody's not had a chance to do it yet, you can get a copy. Well, one person's going to get an OpenFaaS keycap just like that. For the best tweet we get, include a screenshot. And I'll go down to the post office probably tomorrow with that, post it off to you.
Right, I'm going to commit that stuff then. Add Astro checks. Okay, actions. Wicked. Doing some building. See what happens. Yeah. So the interesting thing on the Starlink side is you get access to this whole. I say this is the JSON file. I was just trying to find the absolute path to it. So I was about to do a view source to go grab it, but this is all the data you're getting out of my.
Oh, there it is.
Yeah, but it's for some reason I was just struggling to see exactly where it was. So my exact lat long is it? I know, right? This is the thing I actually love about. Yeah, because if I go into, you actually give you all your stats. So there's my uptime, there's my latency, there's my usage and things. So yeah, it's I can do a
just like what you'll get when you set up Grafana later.
Yeah, that's exactly what I want to be doing.
So do that. Oh, we've broken it.
Oh, okay. Well, it's because I don't know anything about Node. So, publish functions.
Go down. We'll see the error. This is the container build. This is Docker but running. And it was up a bit, was it?
npm.
The npm install is failing for some reason.
Permission denied on package lock.json.
Did you commit one of those?
I did.
We could try taking it away.
Yeah, let's do that. Quick.
I use this template quite a lot. I haven't seen that error, but it's an open source template. You can actually build it on your own machine as well. So if anybody runs into a problem, you can just do a local Docker build with FaaS CLI build, run the image before you push it up.
So do I not want the package lock JSON file? Do I just want?
Let's try taking it off because it had an error about that, and then we can look into it later.
See what happens.
So we don't have a JSON URL for your thing yet, for your router.
Not yet. No, sorry. I was just trying to get this.
On it?
No, not locally. They can just access it because it's only accessible, from inside my network, sort of thing.
Unless you put it behind an inlet tunnel, and then you could get access to your router dashboard from wherever you were in the world.
Yeah.
Put a password on though, and then
one of the things I want to do is build a Home Assistant plugin for it, so I can get all that data through Home Assistant as well. But I haven't got around to that yet.
We've got some good tweets.
Okay.
So we've got Blaze, and he's remembered FaaS Friday. I used to give out, go down the post office, send out loads of swag for the best FaaS Friday tweets, and that was for what people were doing with it, how they were using it at work, with their own projects. So he really likes the MVARs. Me too. And then what else did we get? Istar. Enjoying the live streaming. I've got an eyebrow raised. Jacob caught me with an eyebrow raised. doesn't have Docker installed. So we use code spaces. Yeah.
Why not?
Oh, that's the moment that that's why I raised an eyebrow. Yeah, I think that's definitely a good one. It's like, I thought we went over this. And then Lars training Martin for a change.
Yeah, well, around. This is why I don't. You don't know the answer? You go ask an expert. It's the joys of my job. Right, cool. I've done something wrong in my code, so let's have a quick. I'm just having a quick look here. What I've done wrong.
Well, I think I might have to find a couple of keys actually, because I'm finding it hard to pick between these. Okay. Did it work out, Martin?
Well, it's successfully deployed.
Okay.
But it's my code that I've written is not working. So I clearly can't copy paste node correctly. Oh. Is what's happening. I'll show you how I know that. Well, maybe it does. I was just looking at the code. So it's coming in. It should be doing a get and then dumping.
It's working for me.
Is it?
Yeah, it's telling me there's 13 astronauts in space currently.
Huh.
How's that for it?
Sparkle Pi invoke. Did I need to
might be the way? I think it's the way it's being run because it tends to require a header, that template. But if you copy the URL in the top right,
there's
the other side of the image.
That one.
Yeah.
Yeah, and then kill that
in a new window. Yeah. The OpenFaaS UI is still pretty useful for testing stuff, but I've written a new one for OpenFaaS Pro customers and hoping to get that out within a month or two.
Oh, look at that. There we go.
Yeah. Yeah.
Magic.
And that could be going to your router instead, or Home Assistant, or Raspberry Pi if that had a REST API on it that was serving temperature data.
Well, so the thing that I want to do, that I'm going to go do as part of this once we've switched off the stream, and I know we want to wrap up, if you can sort of see on my Raspberry Pis, I have, let it focus, I have a bunch of these things on, which are little LEDs, and these are running on a thing called an AdaCat Trinky. And I wrote some, which is a little microcontroller, it's like an Arduino.
Is it like a NeoPixel?
It's NeoPixels with a microcontroller running on a USB. And then I have CircuitPython running. I have some code running on it, which is in GitHub, which listens on a serial port. And if you send commands to it, it will light the lights upon the LEDs. And then my plan is to expose that serial port as a TCP port. And then from a Docker container, I can easily call that to be able to change the LEDs, and then I'll be able to change the color of the LEDs from inside my container. So
that sounds really cool.
Yeah, so that's what I'm going to go and try and get working this afternoon, maybe.
What questions do you all have, everybody that's left? And by the way, I'm going to award Blaze and Jacob, so I just can't decide between the two. An OpenFaaS keycap, just like the one I've got down here. You'll get your FASD sticker and inlet sticker as well. Also designed by Heb, by the way, this logo.
Nice.
He's very good at what he does.
Yeah.
So any further questions? You've got me, Alex Ellis UK on Twitter. I'm pretty easy to find on the internet. If you go to my GitHub profile, you can sponsor me if you like what I'm doing. You can also just find out what I've been coding on. And you find Martin Woodward.
Martin Woodward everywhere. GitHub.com and Martin Woodward on Twitter. Yeah,
exactly. So hope everybody has a great rest of the weekend. Thanks for joining us. This has been a marathon session, but it's good to see so many of you here. And if you're watching later on, sorry you missed out on the giveaway, but try it out. Let us know what you're doing with it. The idea is to get you building a pocket-sized cloud on one of these little things, running your own code, and GitHub Actions and the container registry. And then let's just make that extremely easy. So why not give it a go? Great. All right, Martin, thanks so much for making the time. I know you're a very busy man.
Thank you for educating me.
Let me know how you get on with it.
Yeah, we'll do, mate. Thank you, everybody.
Okay.
See you later.
Bye, everybody.